Hello and welcome to another ramble with me. And today we're looking at the department's May 2022 paper 1, question 6. Here we go. The sketch below shows the graph of f of x is equal to minus x squared minus 6x plus 7. So that's a parabola, and we can see from the diagram that it's a sad parabola, right, because of that negative coefficient to the x squared. Right, C is the y-intercept of f. Okay, A and B are the x-intercepts of f. Okay, D, minus 5 and some k is a point on f. Cool. Calculate the coordinates of E, the turning point of f. Okay, so many different ways that you can go about this. There's a video that I've done where I show the different ways that you can find the turning point of a parabola. I think it's one of my shorts. I did say though that I want to just do more calculus in life in general, just because I think, yeah, it is a big topic. It's a topic that you're only introduced to in matric in most cases. So, it is a bit of a new thing that gets that you get baptized into right at the end of your maths career in high school. So anyway, always a good idea to just flex those bones. Do you flex bones? Do you flex muscles? Anyway, so to find the turning point using calculus, we find the first derivative of f, which is going to be minus 2x minus 6. Right, and then we need to figure out for which value of x is this thing equal to 0. Right, essentially we're trying to find the value of x where the tangent to the parabola is going to be flat, where its gradient is going to be 0. That's what we're trying to figure out. So minus 2x minus 6 equal to 0. So that means minus 2x is equal to positive 6. So x is equal to minus 3. Right, so now we found that the x coordinate is going to be minus 3. Cool. So then we want the coordinate, so we want the y coordinate as well, so we can figure out the y coordinate by putting the value minus 3 into the function. So that will be minus 3 squared minus 6 times minus 3 plus 7. So that is minus 9 plus 18 plus 7, so that is 25 minus 9, which is 16. Okay, right, and just to clarify what happened with the signs, minus 3 squared, so minus 3 times minus 3 is positive 9, and then this negative negates it again. Minus 6 times minus 3 gives us plus 18, and etc. and etc. Right, so the coordinates, the coordinates are minus 3 and 16. Right, so don't forget to conclude with that. Okay, so now I'm going to take my diagram to the next page. Hello? Okay, thank you. Right, so next up we have write down the value of k, this guy. So we know the x, so we can find the y by putting it into the function. Right, so k is equal to the output of function f when x is equal to minus 5. So that is what we're going to work out. Okay, so similar to before, we have minus 5 times minus 5, which is 25, and then the minus outside negates it. Minus 6 times minus 5 is positive 30. So this adds up to 37 minus 25, which is 12. So k is equal to 12. Ooh, okay, need my fancy tools for precision. Can I make this even thinner? You should know I'm just being pedantic, aren't I? I am, but I can't help it. I can help it, but I'm choosing not to help it. Okay. Okay, there we go. So k is equal to 12. Doesn't that just look so beautiful? Anyway, right. My diagram is now going to the next question. Okay. So the next question says, determine the equation of the straight line passing through C and D. Okay, so we know the coordinates of D, coordinates of C, it is the y-intercept of f, and we have the equation of f, so we can easily find the coordinates of C. And then once we have that, we can work out the gradient of the line because we'll have the 2 points, and then we'll have the y-intercept of the line because that will be C. So then all is well. So let's do that. So okay, don't want the thin pen anymore. Bring back the juicy one. To find C, okay, we are solving for where, no, we know that the x coordinate of C is 0, right, because it's on the y-axis. So we are solving what is the value of the function when x is equal to 0. So, oops, that equal sign is not looking healthy. So that will be minus 0 squared minus 6 times 0 plus 7. So that term disappears, that term disappears, we're just left with the 7. Okay, so we know that the y coordinate is 7. Right, so then to find the equation of CD, we're going to find the, okay, maybe we don't need to announce everything we're going to do like this. Okay, so the gradient of CD is the difference between the y's divided by the difference between the x's. So that'll be 5 over minus 5, which is negative 1. And visually, that kind of makes sense. Nice negative gradient going on there. So the equation of CD is going to look something like y is equal to minus 1x, which is minus x plus c. And in fact, like I said, we know what the c is. It's going to be 7 because that is the y-intercept of this line as well. So it is minus y is equal to minus x plus 7. Right, looking good, looking snazzy. Off we go to the next part of the question, which says a tangent parallel to CD touches F at P. Determine the coordinates of P. Okay, so time to bring out our ruler. Okay, so CD is something like that. Something like that. Something. Then I let it go and then it just does its own thing. Yeah, when I roll. Yeah, when I roll. My gosh. Okay. So we'll do it in a different color. Okay, so that's our CD, right? Looks like that. Then they say there's a line parallel to CD touching F. Not only a line, a tangent parallel to CD. Okay, and it touches the parabola at P. So obviously if we just keep going down like this, it's always going to intersect the parabola twice. So we're not going to get a tangent. So we need to go this way because we can see that the tangent is approaching. There's the tangent. There it is. Right, somewhere there. Okay, these are parallel lines. Right, so this is the tangent. This is the tangent that we're talking about. And so P is this point over here. P. Oh, P. Oh, P. Anyway, determine the coordinates of P. So we know that the gradient of this line is also then the same as the gradient of this line, which we found previously to be minus 1. Okay, So we are looking for the place on this parabola where this graph, where this curve has a gradient of -1. Okay, and we already have the gradient function of this parabola. It was, whoopsie daisy, it was minus 2x minus 6. No, I don't remember that. I just worked it out again. Right, so we are looking for the value of x where this gradient is equal to -1. So that would be minus 2x is equal to -1 plus 6, which is 5. And so x would be equal to -5 over 2, -2.5. So that is telling us that, I need my special magnifier tools again to just write this as neatly as possible. Okay, so the x coordinate where this tangent occurs is -5 over 2. Right, and again we need the full coordinates, not just the x. So we found the x. To find the y, we just put it into the function. So we need to know what is f of -5 over 2. What is the value of the function when x is equal to -5 over 2? So we just plonk it right in. Oh, the plonking is not plonking, guys. The plonking is not plonking. Okay, right, plus 7. Right, so let's calculate. Oops. And the answer that we get is 63 over 4, which is almost 16. And our visual kind of agrees with that, right? Because remember, yeah, well, this y coordinate is 16. This little p is slightly lower than it in the diagram, slightly lower than e. And 63 over 4 is 15 3/4, so hey, the diagram is not drawn to scale. Maybe it is. Maybe it is. Don't trust the diagram, guys. Please don't go and tell your teachers that I said you can trust the diagram. You can't trust the diagram. Don't do it. Right? So P is maybe -5 over 2 and the y coordinate is 63 over 4. So let me bring back my zoomy thing that I love so much. My goodness. It makes me feel so powerful to be able to, oh my gosh, to write with such precision. Okay, so let's fill in the rest of this coordinate. So it is, oh, yeah, no, akuvumi. Hey, akuvumi mangithule. Hi, akuvumi mangithulo akuvumi. Oh, akuvumi. Right, perfect. So P, those are your coordinates, my friend. On to the last question. Okay. The last question says, for which values of x will f of x minus 12 be greater than 0? Okay, so there's at least two ways that you can think about this. So we are saying, if we were to move this parabola down by 12 units, okay, for which values of x would the graph still be above the x-axis? For which values of x would the y coordinate still be more than 0? So we could think about it as a translation downwards, moving the whole graph down by 12 units. Because what does f of x minus 12 mean? It means take all of the outputs of this function, 16, 12, 7. From all of those outputs, minus 12. So all of these points are going to be 12 units lower than they currently are. So you're taking the whole graph and you're moving it down by 12 units. Okay, so that's way number one that you can think about it. Another way that you can think about it is you can rearrange the equation and say, well, this is the same as f of x greater than 12. So for which values of x is the current graph, or the current function really, for which values of x is the current function outputting values bigger than 12. So if you were to kind of put a ruler here, right, you would say these are the parts of the graph that I'm interested in. What's going on? Oh, right, because this is where the y values are greater than 12. Anything below that, we don't care, because now the y values are smaller than 12, right? So yeah, up to you how you want to think about it. I feel like the second way is, I want to say easier, but you know, it feels easier to me. So that is what I'm gonna do. Thank you. Right. Okay, so we are curious about the values of x that produce this part of the graph. Okay, right. So we already know that when x is equal to minus 5, we get the function gives us 12. And we can see that, okay, anything bigger than that, we keep getting bigger and bigger values, and then we start getting smaller and smaller values. And so what we're curious about is this: when do we stop getting the values greater than 12? When do we go from above 12 to now under 12? Again, a couple of ways that you can solve this. The easiest way, I think, is to think about the symmetry of the parabola, right? So we know that the turning point of the parabola happens here at E. So if we were to draw the axis of symmetry, okay, so that is the line x is equal to minus 3, right? So the distance between here and here is 2 units, right? So then that means the distance between here and here is also 2 units, right? Meaning that the x over here is minus 3 plus 2, which is minus 1. And the y coordinate would be 12, right? So then we would know that for any x value between minus 5 and minus 1, this is where we get this part of the graph. This is where we get values of f that are greater than 12. So the answer would be that x must be between minus 5 and minus 1. And if you see in my previous videos, you know that I like to leave the brackets out, because you know it's always important to think about the boundaries. Do we include the minus 5, the minus 1, or do we not? So let's see. When x is equal to minus 5, the graph gives us a value of exactly 12. We are looking for places where the function gives us more than 12. So minus 5 does not qualify. So sorry, baby, we chop you, right? And similarly, minus 1 also not included. When x is equal to minus 1, our function gives us exactly 12. Again, we are looking for places where f of x is strictly greater than 12. So also you minus 1, we don't want you. So that would be your answer. Of course, another way to write it is that x must be greater than minus 5 and smaller than minus 1. That's another way that you could write your answer. Right, so that's one way that you could solve this. Another way that you could solve it, if you hadn't, you know, picked up on the axis of symmetry situation, or maybe you got your k calculations wrong or something, you could say, okay, I'm gonna solve, I want to find the point of intersection between this line and this line, or I want to find the x values for which this gives me 12, produces 12. Or you could actually even just solve the inequality, like actually, right? So maybe let's do that for fun. So the inequality f of x minus 12 greater than 0, I just replace the f of x with what it is, minus x squared minus 6x plus 7 minus 12 greater than 0, and then minus x squared minus 6x minus 5 greater than 0. Right, and then how do we solve a quadratic inequality, guys? Well, first of all, I do not like the minus, sorry. So I'm going to factor it out. Okay. And then I'm going to times through by minus 1 to get rid of it, or divide by minus 1, whatever. The only thing we need to remember is that that is going to change the direction of the sign. Okay. So that is the most important thing to remember when you manipulate your inequality and you do something that involves timesing or dividing by a negative. Right. So this is now a parabola that is happy. Okay, something like that, maybe, who knows. And we are looking for the parts where this parabola is below the x-axis. We're looking for places where the values are less than 0 or negative. So then we can factorize real quick to say, oh, this is x plus 3 times x plus 2. Okay, so then we know that this is minus 3 and we know that this is minus 2. So then that means that the values of x for which this expression is negative is when x is greater than minus 3, smaller than minus 2. However, this is different to the answer that we got. The horror, the horror, the horror. How did we end up with different answers? Let's see. So we said we are going to say f of x minus 12 greater than 0, minus x squared minus 6x plus 7, which is f of x, minus 12 greater than 0. So this is minus x squared minus 6x minus 5 greater than 0. Perfect. Then, oh, my factorizing is wrong. Sorry. 3 times 2 is definitely not 5. Oh, shocking, Mama T, shocking. But okay, guys, we hold each other, we hold ourselves with grace, don't we? Not a bad idea to double check yourself. Never a bad idea to double check yourself. Unless you don't have time, then it is a bad idea. Okay, I really need to switch off the setting where this thing just turns itself back to whatever it was before I was erasing. It's so annoying. Okay, right. So this is actually going to be x plus 5 times x plus 1. Let's double check that that makes sense. 1x, 5x gives us 6x, 5 times 1 gives us 5. Yes, okay, now we get the answer that we're looking for. Because this will be minus 5, this will be minus 1. And then that means that x must be between minus 5 and minus 1, as we got over here. Perfect. So, yeah, the wonders of mathematics, the wonders of science. Always nice to see different ways to approach a question. Let's see what the memo thinks. You know, the memo might just laugh in our faces and be like, what were you doing? And I will also be like, yeah, what was I doing? Right, so the first question, we agree. We do agree. They also used calculus, fantastic. You can also use the minus b over 2a method. Both should bring you to the same place. Cool. 6.2, we do both get k is equal to 12, which is great. 6.3, so we get the y-intercept, which is 0, 7, and then we find the gradient of CD using the gradient formula, and then we have our answer of y is equal to minus x plus 7. Fantastic. 6.4, yes, we use our calculus to equate the gradient function to minus 1. We find that x is indeed equal to minus 5 over 2. We put it back into our function to find the y coordinate of p, and we arrive at p is minus 5 over 2 and 63 over 4. Then finally for 6.5, their first approach is to use symmetry, and we get that x must be between minus 5 and minus 1. Otherwise, you can solve the inequality, so what we did here in the second approach, and that also gives you the same answer of x being between minus 5 and minus 1. Thank you for tuning in. I appreciate you guys swinging by. I appreciate that you find value in these things, and yeah, catch you another time for another ramble.